Hello everyone, I am Dr. Sonali Revankar. I am working as an assistant professor in Department of Physics at Suryodaya College of Engineering, Nagpur. So warm welcome to all of you. In the video lecture series, we will discuss the most interesting topic in engineering physics is laser. We have started Unit 5, laser. So these are the content. What is laser? Then we will discuss what is basics of laser, characteristic of laser, working of laser, types of laser and application of laser. So first of all we will discuss what is meant by laser. Laser stands for light amplification by stimulated emission of radiation. A laser is a device that emits light through the process of optical amplification based on stimulated emission of radiation. Then what are the properties of laser, or we can say that the characteristic of laser. Laser light should be monochromatic, laser light should be highly directional, laser light should be highly intense, laser light should be highly coherent, and it has a very low divergence power. Monochromatic means having single wavelength, means laser light should have a single wavelength. So these properties makes the laser light different from ordinary light. Then we will discuss the basic concept in lasing action. So there are three quantum mechanical process involved in this lasing operation. Number one is induced absorption, number two is spontaneous emission, and number three is stimulated emission. So these three process plays a very important role in lasing action. One by one we can discuss. First, number one is induced absorption. Here consider an atom in a lower energy state E1 as shown in the figure. The atom may absorb an incident photon and jump to the excited state E2. This transition is known as stimulated absorption or induced absorption. Here E1 is the ground state and E2 is the excited state. So from the atom which was present in the ground state E1 absorbed the energy of photon h mu and jump to the excited state E2. Then spontaneous emission. An atom is in excited state. It may spontaneously decay into a lower energy level after some time, releasing energy in the form of photon, which is emitted in a random direction. This process is called as the spontaneous emission. So this type of process in which photon emission occurs without external any help is called as the spontaneous process. Means there is no need of any external agent to come down the photon from higher state to lower state. Then stimulated emission. Stimulated emission is the process by which an incoming photon of specific frequency can interact with an excited atom electron, causing it to drop to a lower energy level, giving up two photons as shown in the figure. The phenomena of forced emission of photon is called as the induced emission or stimulated emission. So this emission, stimulated emission, plays a very important role in lasing action. Here there is a multiplication of photon, and the photon we get, they are identical in nature. Then we will discuss three level laser system. There are two level system here. So first we discuss three level, and after that we will discuss four level laser system. In a three level system, the name itself indicate that there are three level including, that is E1, E2, E3. So E1 is the ground state and E2 is the metastable state, means where the atom can stay for a shorter period, that is 10 to the power minus 6 to 10 to the power minus 3 second. That state we call as the metastable state. Then excited state, here electrons are pumped from the ground state to the high energy state by an external source, here using photons or electrical energy. Then working principle, here electrons are excited from ground state to excited state by absorption of pump energy. Then electron quickly decay non-radiative from E3 to E2 transition, and in step 3 from E2 electron returns to E1 by emitting a photon producing laser light. So here population inversion is achieved between E2 and E1 state. Example, ruby laser is widely known 3-level laser. Then 4-level laser scheme, again here the name itself indicates that there are 4 level, because the name itself indicates that it contains 4 level. A 4 level introduces an extra energy level above the ground state. Here again E1 is the lowest energy level, or we called as the ground state. Then E2 is the lower lasing level just above the ground state. Here electron drops here after the laser action. Then metastable state, electrons have a long lifetime here and population inversion is easy to achieve between E3 and E2. Then E4 is the highest energy state where electrons are pumped first. Then working principle, pumping excite electron from E1 to E4. Then rapid non-radiative decay from E4 to E3. Laser emission occurs as electron go from E3 to E2. Finally, electron decay from E2 to E1. Here population inversion is achieved between E3 and E2 state, which is easier than 3 level system because E2 is not the ground state and remains nearly empty. Nd:YAG laser is the example of 4 level system. Then what are the components of the laser? This is the most important part of the laser. Number 1 is the pumping source which is required. Then number 2 active medium, and number 3 optical resonator. Then pumping means what? To supply energy. Optical pumping is a process in which white light is used to raise pump electron from lower energy level in an atom or molecule to a higher energy one. It is commonly used in laser construction to pump the active laser medium so as to achieve population inversion. Example of pump source, there are various types of pumping: electrical pumping, flash lamp, arc lamp, light from another laser, chemical reaction. Then second is the active medium or lasing material. It is the material in which the laser action takes place. The active medium may be solid crystals such as ruby laser, liquid dyes, gas like helium, neon, CO2, or semiconductor such as gallium arsenide. The medium decides the wavelength radiation. Active medium contains the atom which can produce more stimulated emission than spontaneous emission and cause amplification. They are called as active centers. Then optical resonator. An optical cavity is an arrangement of mirror. Here there are two types of mirror present. One is 100% reflecting and another is a partially reflecting. Then types of laser. Actually lasers are classified into 5 types based on the types of laser medium, but in engineering we will discuss only 2 laser, that is solid state laser and gas laser. That is ruby laser is the example of solid state laser and helium neon laser is the example of gas laser. So here is the classification of laser. Then we will discuss in short what is ruby laser. Ruby laser was invented by T. Maiman in 1960, which is a solid state laser that emits short intense pulse red light at 6943 Armstrong. It uses a synthetic ruby crystal, means here is a mixture of Al2O3 which is doped with chromium ions as the gain medium, typically pumped by a xenon flash tube to achieve population inversion. It is known for producing high energy pulse, primarily used in dermatology and holography, and it follows 3 level pumping scheme. Then next is the example of gas laser, that is helium neon laser. A helium neon laser is a gas laser consisting of a mixture of helium and neon with a small bore capillary tube. Here is the ratio of helium and neon is, that is 10:1. It was the first gas laser invented by Javan et al. In 1962 at Bell Telephone Lab. It operates continuously in the red, infrared and far infrared region, and the most widely helium neon laser operates at a wavelength 632.8 nanometer in the red part of the visible spectrum. Then application of laser. Laser in industries. Laser can be used to blast holes in diamonds and hard steel. Number 2, laser can cut, drill, weld, remove metal from surface. and laser range finder is used to measure distance to making map by surveyor. Then laser in medical science, argon and CO2 laser are used in treatment of liver and lungs, new kind of laser surgery that uses molecule to stitch together wounds. CO2 laser is particularly used in spinal and brain tumor. Lasers are used in the treatment of glaucoma, and the laser can also repair a detached retina, one that has a broken loose from the rear part of the eyeball. The laser is very useful in removing extraneous blood vessel that can form on the retina, light sensitive membrane at the back of the eyeball. Then laser in military, a laser beam can be bounce off targets such as enemy airplane or ship to determine its distance and speed. Laser can serve as a war weapon. High energy lasers are being employed to destroy enemy and aircraft and missiles. Then lasers in engineering. Lasers are used in engineering for precise material processing, including cutting, welding, drilling and marking across industries like automotive, electronic and aerospace. They offer high speed, non-contact and automated solution for micro machining, additive manufacturing and surface modification. Key applications include LIDAR, fiber optic communication and industrial metrology. Fiber optic communication, in which laser provide high speed long distance communication, which is used in transmission and communication networks. Then laser scanning microscopy, in which used to inspect microstructure in a material. Then in Moscow, a laser centering device was used to control the vertical axis during the construction of TV tower with a precision of 6 mm. 6 mm means 6 into 10 to the power minus 3 meter. Laser directional finders are widely used in coal mines. In a view of the high rate of digging in coal mining, the biggest difficulty is to maintain accurately the given direction, which is achieved using a highly directional beam. Similarly, geodolite is used for detection and measurement of the deformation of large dams and bridges. Then, thank you for watching my video.